Now, yesterday's lesson was only a day ago, so I expect students to remember what we did. Canan, James, and Min, leave it at home. Do not waste my time. 3, 2, 1. Canan, are you even there? I'll take that silence as a no. Oh, there he is. Good. Yeah, get excited for today's lesson. Alex, what did we do last lesson?
Hyperloop.
Hyperloop. Yes, we studied the Hyperloop with Elon Musk and how it is an innovation in transport using renewable energy source. Okay, and that being solar.
Like,
yeah. Get you to Ho Chi Minh in 1 hour and 10 minutes. That is quick. All right.
super quick.
There are lots of other examples of innovation using renewable resources, and over the next 10, 20, 30 years, we should see a lot more. So keep your eyes out as you get older. All right, just cleaning my glasses and we can begin because now I can see. Fantastic. All right, we're going to get straight into today's lesson because we're learning another new concept today. Now, if I say energy efficiency, does anyone have any idea what I'm talking about? No? Okay. Well, we're all going to learn something new today then. All right. And here we are. So, Lisa, what is energy efficiency?
Energy efficiency means to products or technologies that perform the same function but consume less energy.
Yeah, perfect. Yeah, so you missed out a word there. But energy efficient means to use products or technologies that perform the same function but consume less energy. For example, class, the first light bulb that was invented uses a lot of energy. Does anyone know the name of the newest light bulb we use that gives out the same amount of light but uses a lot less energy? No? Well, it's called LED and we're going to study it today. So class, in our world today, we have many products. Okay, a lot of our old products use a lot of energy, but designers and engineers designed new products that do exactly the same thing, but use less energy or use less electricity. All right, same function, less energy. And that's what we're going to be studying today. All right, and you know what? We are going to come back to that example. All right, class. So first, let's get into a little bit of reading, and then we're going to watch a little video to help us understand this topic. Okay, so let's break this reading down into 2 parts. I'm going to have a pink, and I'm going to have an orange. And Sophia, hand up straight away. So Sophia, please be my pink reader. Katie, be my pink highlighter. Lisa, be my orange reader, and Livy at home, be my orange highlighter. Okay, so pink reader, please begin. Everyone, listen carefully.
Going green debate.
Sophia, what about the rest of the paragraph? Oh, no, I think her camera's just gone.
Energy. How can I read
This
that?
efficiency.
Mr. Jake.
Yeah. I just told you, efficiency.
How can I read the word after energy?
Yeah, I've told you twice now, efficiency.
Oh, it's a little bit a problem in internet.
Okay, that's fine. So, efficiency.
Energy,
Let me break it up for you. Let me break it up for you. It's a difficult word. So we're going to go E.
Efficiency.
David. Efficiency.
Efficiency
Nice. Yeah, good.
means to use products or technologies that perform the same function but consume lower recent bulb is more energy efficient than a traditional
Incandescent.
bulb.
Yeah, good. So, Sophia, like you said, your internet's not very good, so a lot of that lagged out. But from what I heard, it was good reading, but I am going to read it again just so everyone hears it. Energy efficiency means to use products or technologies that perform the same function but consume less energy. For example, a compact fluorescent bulb, which is this one here, uses less energy or consumes less energy. Sorry, let me say that again. A compact fluorescent bulb is more energy efficient than a traditional incandescent bulb. Okay. So just from that, before we get the next reader, David, which bulb do you think is the oldest?
The oldest is the high efficiency incandescent. Yeah,
incandescent bulb. And what we can see here, class, is watts is how we measure electricity. So 43 watts is a big number. 15 watts, small number. So
43 watts is very large amount of light.
So it's not how we measure light, David. It's how we measure electricity. How we measure light is something called lumens.
I forgot. I say different.
It's fine. Don't worry, but David. So, class, what we've got here is an old bulb uses more energy. New bulb uses less energy. But the light that they give off is exactly the same. All right. So new technologies means we can use less energy. Okay. Sorry, Lisa. You can now continue.
It used much less electrical energy to produce the same amount of light. How do you think renewable energy and renewable and non-renewable resources compare? Which one do you think is more energy efficient?
Okay, so today's question, and we're going to be doing a bit of writing on this, is a difficult one. We don't want to know which one's better for the environment. We want to know which one is more energy efficient. Okay, so if we're using coal, do we have to use more coal than sunlight? Do we have to use more uranium than we do tidal energy? Okay, these are the types of questions we're going to look at today. Which one is more energy efficient? Which one can we use less energy for the same functions? All right, so today's question is quite a difficult one, but that's why I've left it for the end part of lesson 2. So, class, I think we can answer that question at the bottom now. Out of these 2 light bulbs, which one uses the least amount of energy? And please tell me if it's the old one or the new one. So I'll finish this question at the bottom and then we're going to watch a little video. And as far as highlighting goes, Katie, leave it at home. Good job. You've got all of the keywords there. That's fantastic. So which one of these light bulbs uses the least amount of electrical energy? These 30 more seconds. Make sure you're writing that down on your handout or in your notebook. You know how this works. Okay, and then Katie, can you give me the answer?
The one who uses the least amount of electrical energy is the compact fluorescent, 50 watt.
Perfect. Yeah, 15 watt. Yeah, good. So as long the number, whichever one that has the smallest number uses the least amount of electricity. Brilliant. All right, make sure you get that written in class because we're going to check out this video now. It's going to show us the difference between 2 concepts. once this advert finishes. Okay. So I'm going to have the sound on for this one, class. So if it does lag, please turn off your cameras. Also, class, you will notice that in your handout, oh no, that's for the second video. Don't worry, ignore me. Okay. So we're going to watch 2 videos today, class. For this one, I don't need you to take notes. I just need you to listen very carefully. All right. I may stop and start it to help explain things. I want to put the, auto captions on. And we're going to have a little look. So 2 concepts we're going to look at: energy conservation and energy efficiency. Now, we're going to mainly look at energy efficiency today, but it's good to understand what conservation is.
People are increasingly trying to find ways to reduce their carbon footprint. This can include taking a closer look at the way you use energy, including products you choose to use, and even your activities. To support you on your green journey, we'll break down 2 terms you're likely to hear when it comes to becoming a more thoughtful steward of your energy use.
I'll slow it down a little bit.
The first concept is energy conservation. This is when you cut back on the actual energy being used. For example, conserving energy could mean taking a shorter shower, turning off lights when not needed, or commuting to work by bike instead of by car.
So class, energy conservation means you using less energy. So Lisa, does my house look bright right now?
I think it doesn't look that bright, but it's okay to see you.
Yeah, it's okay to see me, so it's enough, right? But that's because I don't have any lights on behind me. Okay, I don't have any lights on behind me. You can see my face better in the camera. But also, I'm conserving energy by not using energy I do not need to use. Okay. So you can see Sophia's got so many lights on. But Sophia, I'd also want to see your face today. So can you move your camera? James, I'm a bit tired of looking at your forehead too.
Mr. Jack?
There we go. David, yes.
I don't understand how could they measure the amount of electricity.
They're not measuring anything. We're just conserving it. We know that if our lights are turned off, we're not using energy. That's how we can measure it. It's really simple measurement. So like if you take a shorter shower, you're using less energy. If you take a shower for 2 minutes, you're using less energy than you would be if you took a shower for 5 minutes. Okay. If you have your lights on for 1 hour, you're using more energy than if you had your lights on for 5 minutes. Yeah? Does that make sense, David? So this is energy conservation. This is just you being smart about how much energy you use.
Taking a short shower.
So that's just an estimation, right? It's just an estimation.
Yeah, we don't need to know the small details, but we know if we use energy for less time, we are being energy conservative, or we are using energy conservation.
When we're using a shower for less time, we can
Think of it this way. If you are playing games on your laptop, all right, and you need to go away and eat dinner for 15 minutes, do you turn the laptop off or do you leave it on?
make it sleep.
Yeah, so sleeping is not even that good. Yeah, you should turn that laptop off so the laptop stops using energy. That way it costs your parents less money for electricity and you're saving energy. If you leave a room, turn the lights off, you'll be saving energy. Okay. People who leave lights on when they go to another room, they're just lazy. Okay. There's so many ways we can do energy conservation.
The next is energy efficiency.
Now, this is the one we're going to study, class, because this one's a little bit more complicated.
The distinction is that you aren't changing behaviors, such as avoiding energy use. Instead, you're cutting down on the energy required to achieve the same result. Take a light bulb, for example. Changing out your older incandescent bulb in favor of an LED version can reduce the amount of energy required to achieve the same desired effect of lighting your home or business.
So, class, in a shorter way, this incandescent light bulb uses lots of energy. So we swap it for an LED that does not use a lot of energy, but gives us the same amount of light. This is when we rely on our products to make or to use less energy. And that is energy efficiency.
Ultimately, when trying to reduce your carbon footprint, taking steps to conserve while also being more efficient is ideal. Every little bit helps. For more bright...
So, class, really, really simple question, but let's see if we can get it. Admin, why should we save energy? Why should we be energy efficient and energy conservation?
So we can reuse it.
Yeah, can we use it, but more to the point, we can save it. Go on, David.
We can save electricity and we will not harm.
Yeah, you'll harm less. Yeah, you'll harm less. It's just a good right thing to do. Okay, because some of us get our electricity from a dam, we'll get it from coal, we'll get it from uranium. A lot of our energy comes from fossil fuels. So if we just use energy like, oh, I'll leave the lights on, oh, I'll have a really long shower, it will speed up how quickly we run out. All right, we don't want that, do we? We don't want to run out. That would be annoying. Can't play our games anymore on our laptops. We ran
ideas.
Oh no.
In Vietnam, we mostly use hydroelectric.
48%. But if all of that's less than half. The other half is fossil fuels. So we still need to be careful.
That's the renewable thing they use.
Okay, class. So I want us to look at this picture first, and we're going to watch another video. All right. So, James, what do you see in the picture?
Diagram.
Say that again. Yeah, diagram. Do you know the name of this diagram?
A circle diagram.
Close enough. We call it a pie chart. So it looks like a pie. Okay.
Pie chart.
A pie chart. This is what we call it in England anyway. So this is the pie chart, class. Now, this pie chart is showing us all of the energy that is being used in an average house in England. So remember, England's very cold. So 60% of our energy goes to heating our houses. Okay. So 19.3% goes to water heating. Appliances like dishwashers, washing machines, things like that, 13.6. Lighting, 3.6. Space cooling, 1.9. So class, we're not going to answer this now, but what I want you to think about whilst we're watching the video is if we could only change one of these to renewable energy, which one should it be? Now, we're not going to answer this now. I want you to think about it.
That would be a very, 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 very difficult one.
No, it's super easy if you think about it. But we're not going to answer it now. You're going to think about it whilst we watch the next video. And for the next video, class, on the next page, you'll see I've given you an area to write some notes. Okay, so this next video, I want you to write a few notes about what's happening and what you're learning. So make sure you have a pen or a pencil ready.
Can I write in my science note?
You can write in your notebook if you want, but I'll just put this down in case you don't have one. As long as it's somewhere safe, David, that you will not lose, that is fine.
I always keep it.
Good, good. Also, seeing as I know a few people are struggling with this word, let's go back. All right, class, everyone, turn your microphones on before we watch this video. Turn your microphones on. We're just going to practice this word.
My house is a bit noisy, so.
David. All right. Class, turn your microphones on. I will not ask you again. Lazy, lazy, lazy.
My room is a bit
And Min,
noisy.
you're smiling, but you're not turning your microphone on. Come on, you're wasting my time. Microphone's on in 3 seconds or I'll kick you out. 3, 2, 1. What is it? Can no one hear me?
Already.
Yeah, I know you have. Some people haven't though. Alex is gone. Sophia's gone. James, you're about to be kicked out. Turn your microphone on. No, Lisa. Turn your microphone on. There we go. All right, class. Here we go. Efficiency.
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 Now do it like a sneeze. Efficiency.
Efficiency.
Hey, see, we're getting it. We're getting it. Nice. All right, very good.
My little PPT pencil.
Okay.
Oh, man.
What is energy efficiency?
Oh, nice. Came up straight away. All right, class. So, like I said, this is more of a note-taking video. I will slow it down. I will pause it so you have time to take notes.
Mr. Jack, I haven't found my pencil anywhere.
Well, you got to hurry up, David.
Can I use pen?
Yeah, I really don't mind. All right, class. So, everyone ready? Stick your thumb up if you're ready. I got 1 thumb up so far. I got 2. Oh, everyone died this morning. All right, Canan, get that camera on before you annoy me. Let's go.
Energy efficiency is one of our most overlooked energy solutions. We use energy to provide a lot of services. If we can use less energy to perform the same task, that's more efficient. Energy efficiency is generally expressed as a ratio of useful work or energy output to its corresponding energy input. The less energy a system requires to produce a desired output, the more energy efficient that system is.
So look at that, class. As long as the input, the electricity, is smaller than the output, which can be any function in a house, it is considered energy efficient.
Mr. Jack, can you say it again? I can't hear you. My internet is starting to lag a bit.
That's okay. I'm going to do that, but I'm also going to show you an example. So look, class. I'm doing the crocodile mouth, but I'm doing it vertical. So as long as the input, which is electricity, is smaller than the output, which is the function of whatever's in your house, then it is energy efficient. The smaller the amount of electricity you need for your function, the more energy efficient your function is. So I'll write that out in a different way for you as well. I'll just do it to one side at the top, well, actually at the bottom so you can see. So electricity needs to be, where's my math symbols? Well, I'll have to draw it, I guess. Function. There we go, and then I'll just draw. There we go. So you can see at the bottom, class, as long as the electricity amount is smaller than the function, we are being energy efficient. All right, let's keep this going.
Let's try an example. Compare a 12-watt CFL bulb to a 60-watt incandescent light bulb. Both can produce the same amount of light measured in lumens. If we use both bulbs for 1,000 hours, the CFL bulb will have used 12 kilowatt hours of energy, whereas the incandescent bulb will have used 60 kilowatt hours of energy.
So again, class, we're seeing that the incandescent has the larger energy numbers, but has the same output as the energy efficient light bulb. Yeah, so the output is the same. The amount of energy used, very different.
Most electricity bills are charged per kilowatt hour, so over time, these energy savings across appliances will result in cost savings too.
So there's a nice little bit of maths there if I turn the things off. So efficiency, again, smaller input, bigger output, okay? As long as the output is bigger than the input, we are being efficient. All right, I'll keep this going.
This is so mathematic.
Mathematic? I mean, all science is mathematics, David. They're like brothers. You can't do one without the other.
We can apply the same output divided by input formula to compare other things. The efficiency of two different modes of transportation, heating systems, or even the land and water use efficiency of two food products. Energy efficiency applies to more than light bulbs. For instance, houses where less air escapes take less energy to heat and cool. Cars that are run with electric motors and powered by batteries waste less heat, so they can go further on fewer joules of energy. However, the overall efficiency and overall greenhouse gas emissions would also depend on how the electricity is produced.
So, class, this is very interesting. Remember, energy efficient electricity will come from certain places, and non-efficient electricity will come from others. It's up to you to figure out which ones.
Non-renewable resource.
Yeah.
Is energy efficiency the same thing as energy conservation?
So we should know from the last video, no, two different things.
No.
Energy efficiency is our products using less energy.
But we
Energy
have the same
conservation is people using less energy. So to help you guys out, energy efficiency is all about products. Energy conservation is all about people.
people and human.
People are humans, but yeah. Okay, so energy efficiency, how we can get products to use less energy. Energy conservation, how we get people to use less energy. Turn lights off when you leave a room.
Energy conservation refers to reducing overall energy consumption. This may involve technological improvements, but energy can also be conserved by changing lifestyles and behaviors and reducing energy losses. Increasing energy efficiency means delivering the same service using less energy.
So that's a nice little tagline you probably want to write down, class. Energy efficiency, delivering the same service with less energy, or performing the same function with less energy. All right, very good. Because you are going to have to study this for part of your homework. So it's good that you have your notes clearly written down. And keep an eye on the time. Oh, wow. Getting through it already.
Delivering a higher useful output for the same input energy traveled.
Now look at this bit now.
Improving energy efficiency in buildings, transportation, shipping, and other energy-intensive processes is one of the most important ways we can reduce greenhouse gas emissions and fight climate change. But unfortunately, global improvements in energy efficiency have been declining. By investing in energy efficiency across sectors and advocating for climate policies that prioritize energy efficiency, we can not only reduce emissions, but create millions of sustainable energy jobs in the process.
So that's pretty much it on the energy efficiency class. I'm hoping you got some good notes down. All right, everyone turn your cameras on, get back to class. So, James, I want to talk to you about this circle diagram, or also known as a pie chart. All right, so James, turn your microphone on for me, buddy. All right, so James, which part of the pie chart is the biggest?
The red part.
And what's the name of the red part?
Space heating.
Yeah, so think of an English house, James. We use 61.6% of all of our energy on space heating. Which is the smallest, James?
The blue one. The
blue one?
dark blue.
Yeah, and what's the name of that one?
Space cooling.
Space cooling. Now, everybody, I'm going to tell you now that these are all non-renewable. Non-renewable, not very efficient. Okay. Now, you can only change one of these to be a renewable energy source. Which one would you choose to have the biggest impact on your house? James, what do you think?
Space heating.
Why do you think that?
Because because the energy used on it is the largest on the house.
Yeah, it's the largest, it's the most energy we are using is going into space heating. So I think you're absolutely right, James. So yeah, we should change that to a renewable resource. So class, you'll see at the bottom of this page. Sorry, Ronaldo, read the question to everyone at the bottom of the page, please, and everyone should be able to answer it now. Ronaldo.
To be energy efficient, which part the chart would you change to a renewable energy source?
Perfect. Okay. James already gave us the answer. Were you all listening?
I'm listening.
I hope you're all listening. Katie, were you listening?
Yes,
Good. So you know the answer?
I'm thinking.
Well, you can't be thinking because James already gave you the answer. So you were not listening. All right, everyone, ears up. Katie, which color in this chart should I change to a renewable resource and why?
Space heating.
Okay, why? You're right. I just need you to tell me why. Why have you chosen space heating?
Because space heating takes most part of the pie chart, and like space heating, it is bad for the environment.
Yeah, it depends where it comes from. If it comes from non-renewable, then yeah. Okay, but what we're doing now is changing it to a renewable resource because it uses the most amount of energy. So we're going to try and change that. Yeah. So yeah, class, make sure you put space heating there and we can move forward. Now, there was a quiz at the end of today's class, but I think we'll do it tomorrow because I don't think we're going to have enough time, because more importantly, there's the next page. Class, question 14 in your textbooks is something we're going to start now and something you're going to finish for homework. Let me explain how this is going to go. I am not going to help you with your answer at all. Okay, so the whole point of this question before we go through it is to incite a slight debate next lesson. I want to see if we can do this. I want to see if we're old enough. You're all going to answer this question and give evidence for it. Now, a lot of you should have different answers. And next lesson, you're going to bring your homework to class and you're all going to discuss your answers and discuss why they're different. Okay. So first off, let's understand the question. It'll make a little bit more sense. Leave it at home. Please read question 14 to the class.
Consider both types of energy resources, then fill out the table below.
Okay, keep going. Under claim.
Under claim, fill in either renewable or non-renewable to complete the sentence. Then under evidence, give 3 facts that support your claim. Use facts from this lesson and the previous one. Research any other facts you need to use as evidence.
Perfect, very good. And then look here, class. So this is it, the claim and the evidence. So what you're going to do now, actually, no, you're not going to do any of this now because I need you to go research. So once you're ready, you're going to finish this claim sentence. I think that energy is the most efficient type of energy. Your choice is to use renewable or non-renewable. Then class, you need to find your own evidence. You might find some evidence in the textbook, which is great, but you will probably need to research this as well. Okay. You need to go online and study which one is more efficient. Is it renewable or is it non-renewable? Okay. So this is a very individual homework. I'm not going to help you with it because I want I want a lot of different answers. Okay. If I help you with it now, we'll all have the same answers. We won't be able to communicate our ideas. All right. So usually a homework's in for Sunday class. This one needs to be with you tomorrow because we're going to spend the first 10, 15 minutes discussing your answers. Okay. So does anyone not understand what they're doing for homework? Speak now or forever hold your peace. I know it's a little bit of a weird one.
So we need to research about this homework?
Yeah, do your own research. There'll be some evidence in your textbooks, but not all of the evidence you need. So research your textbook and research online. Do both. Okay? It won't take you too long. I wouldn't worry about it. But you need 3 pieces of evidence to support whether you think renewable is efficient or non-renewable is more efficient. All right? And I expect everyone to have that homework tomorrow. This is not a Sunday homework. It's the only homework this week that's not a Sunday homework. So, class, this is your last chance. Does anyone need anything else explaining about the homework? All these silent foreheads. So that means everyone understands, right? Yeah, Kanan, do you understand?
I try my best.
Yeah, you understand, Kanan?
I'll try.
Yeah, everyone tries their best. That's all I want in this class. Try your best. Read everything carefully. So class, in case you didn't know, this is question 14. It is on page... sorry, I didn't give you the page number. Oh, I've been kicked out of it now. That's annoying. Lisa.
69.
Can you find the page number for everyone, please? I've been kicked out of the website. That gives me it.
It is page 557.
557, brilliant. I'm going to put that in there. Thank you very much. All right, class, if you know the page number and you know what you're doing for homework, well done. I will see you all tomorrow. Page 556. All right, have a good day, class. I'll see you all soon. Bye.